Welcome back to the Explainer. I'm so glad you're here today because we've got a fantastic deep dive lined up. Look, if you've ever stared down enterprise-scale technical documentation and felt, well, a little overwhelmed, you're definitely not alone. Today, we're taking the incredibly rich and, let's be honest, somewhat dense index of the Azure Health Data Services documentation and flipping it into a dynamic, easy-to-follow roadmap. Whether you're an IT architect, a developer, or a healthcare data pro, we're going to unlock exactly what Microsoft's powerful suite can do to completely modernize your health infrastructure. Let's get right into it. Okay, let's dive into this core promise. Collect, transform, and analyze health data that meets privacy and compliance requirements. Now, that is not just some marketing tagline. It's actually the ultimate high-stakes challenge in modern healthcare. We're talking about managing some of the most sensitive, highly regulated data on the planet. Healthcare organizations are out there right now totally bogged down trying to make completely disparate systems talk to each other, all while dodging compliance landmines left and right. Azure Health Data Services is designed to be that single, unified cloud environment that basically takes that massive burden right off your shoulders, letting you focus on what actually matters, improving patient outcomes through data. So, here is our roadmap for today's explainer. First, what are health data services? Second, standardizing FHIR and imaging data. Third, automating and optimizing workflows. Fourth, de-identifying health data. And finally, resources and important migrations. Starting off with Section 1, what are health data services? You know, before you can transform healthcare, you really have to build your foundation. And the docs lay out an incredibly clean step-by-step onboarding process for this. First up, you set up a workspace, which acts as a logical container for all your health data instances. Next, you actually deploy the Azure Health Data Services into that workspace. Step 3 is registering an application. This one's absolutely essential because it allows your custom software to securely talk to Azure's APIs. And finally, setting up user access and permissions. Oh, and a vital detail here from the documentation, this isn't just for human users. Azure gives you these really robust options for granting permissions directly to a managed identity. That keeps your automated backend services locked down and highly secure, so you're not stuck juggling hard-coded credentials. It's a real lifesaver. Let's move to and see how this builds into Section 2, standardizing FHIR and imaging data. So Azure takes this amazing dual approach to the two biggest behemoths in health data, FHIR and DICOM. On one side, we have FHIR data, Fast Healthcare Interoperability Resources, which is basically the modern gold standard for clinical data. The documentation goes deep on configuring cores, cross-origin resource sharing, so your web apps can actually access this data safely. It also walks you through tools for CMS operability and direct patient access, basically making sure you're hitting those federal mandates for data sharing. But hey, clinical text is only half the story, right? On the other side, we have imaging data, powered by Azure's DICOM Service. Fun facts for you. A single medical imaging study can easily exceed a gigabyte. Azure doesn't just store these massive files, it literally empowers you to use that image data for advanced analytics and cutting-edge digital pathology. You get distinct, highly specialized toolsets tailored perfectly for both of these formats. Next up, Section 3, automating and optimizing workflows. Healthcare moves incredibly fast, and your architecture absolutely needs to respond in real time. Azure Health Data Services supports a fully event-driven architecture, and the documentation puts you in total control of the whole shebang. You can deploy events straight from the Azure portal. So if a new patient record gets created or maybe a massive scan is uploaded, it can instantly trigger a downstream workflow, like pinging a doctor or updating a real-time analytics dashboard. But you're never flying blind here. The docs show you exactly how to use event metrics to monitor performance, how to safely disable events when you need to do maintenance, and, crucially, how to troubleshoot things when they inevitably go a bit sideways. This whole menu of capabilities really empowers you to streamline operations and take absolute control of your data flow. Moving right along to Section 4, de-identifying health data. Look, when you are stripping protected health information out of a data set, whether that's for research, training an AI model, or secondary analysis, the stakes are through the roof. Literally, one misstep can cause a massive compliance breach. So when you're setting up your de-identification services, the very first question you have to ask yourself is this: how do you manage access to make sure only authorized entities can perform this highly sensitive operation? And this brilliantly illustrates Microsoft's built-in enterprise security infrastructure. You manage access with Azure Role-Based Access Control, or RBAC for short. You don't have to go out and invent some custom security model for your health data. You leverage the exact same granular access control system that secures the rest of the Azure ecosystem.
You get to define exactly who or what can read, write, or de-identify data, based strictly on their specific role in your organization.
The de-identification documentation functions like a complete developer toolkit. It walks you through deploying the specialized service, locking it down with that Azure RBAC we just talked about, and securely connecting using managed identities. But honestly, the real standout feature for developers here is the ability to de-identify health data programmatically using the .NET SDK. Think about that. You can integrate powerful automated data masking directly into your custom applications and data pipelines. It makes privacy a seamless, baked-in part of your code, rather than some manual, tedious afterthought. A total game changer.
And finally, Section 5, Resources and Important Migrations.
Microsoft provides this absolutely massive array of resources to accelerate your build. Digging into their GitHub repos, you get immediate access to sample apps, converters, and code for Azure Health data and AI workflows, meaning you don't have to start from scratch, ever. There's a comprehensive REST API reference for those deep technical integrations. If you're looking to automate your infrastructure deployment, they've got Quick Start ARM templates ready to go. And if you want to stay ahead of the curve, the Healthcare and Life Sciences blog is just an incredible resource for insights and best practices straight from the experts. It's basically an a la carte menu for developer success.
But alongside all those great resources is some critical operational news you absolutely need to be aware of. So the crucial point is this ticking clock. If you are currently using the older Azure API for FHIR Service, you need to start planning your migration to the unified Azure Health Data Services today. Why? Because on September 30th, 2026, the legacy Azure API for FHIR is officially retiring. Now, the documentation does provide dedicated migration strategies to help you move your data smoothly, but make no mistake, this is a vital layer of planning you need to add to your IT roadmap right now. Don't wait on this. We have covered a tremendous amount of ground today, from that initial deployment and standardizing really complex clinical and imaging data, all the way to automating workflows, ensuring airtight privacy through de-identification, and getting ahead of future migrations. Azure has laid out a highly structured, incredibly robust toolkit designed to handle some of the most demanding data on Earth. So I'm going to leave you with this final thought. With all of these powerful, compliant Azure capabilities now at your fingertips, what's the very first healthcare workflow your team is going to modernize? Thanks so much for joining me on this explainer, and happy building.